factoring some special products that follow a pattern involving some perfect squares. So the more you can have these perfect squares memorized, the easier identifying this pattern will be. So again, we're on 7.7, and before we get started here, we're going to do a very quick review over some multiplying real fast. So I'm going to start, and we're going to multiply. We're going to multiply 3x minus 2 squared. Now remember, we cannot distribute powers to sums or differences, so I would not be able to say that that is 9x minus 4 because you can't distribute powers. You have to expand that. So what would that look like expanded? So you just write it twice. Someone said last hour. And then you multiply it. So you can do box method, distribution, FOIL, whatever you want. I want this to go kind of quick, so I'm just going to quickly do, I'm going to do FOIL because I haven't done that in a while. So first times first, 3x times 3x is 9x squared. Outside, 3x times negative 2 is negative 6x. Inside, negative 2 times 3x is negative 6x. And then last, negative 2 times negative 2 is positive 4. You can use box method whenever you want. I'm just trying to make this go a little bit quicker. And then we combine our like terms, and what's negative 6x plus negative 6x? Negative 12x, and then plus 4. And that'd be our answer. Okay? The other type we're going to see today would be something like this. Let's do... First of all, what is true about those two binomials? One's negative, one's positive, but other than that, they're identical, right? Just one's plus, one's minus. Cool. If we multiply those really quick, I'll do distribution this time. What's 4x times 4x? 16x to the second. 4x times negative 5 is negative 20x. 5 times 4x is positive 20x. 5 times negative 5 is negative 25. Add your like terms. What's negative 20x plus 20x? Cancels out, and here's what you're left with. So today we're going to actually be starting with these answers and working backwards to get to here. They're just patterns. Okay? Awesome. Really good attitudes about it too. So we're just going to factor patterns today. All you have to be able to notice is whether or not the first and last term are perfect squares. If they are perfect squares, then it's probably going to fit one of these patterns. I think this one's really easy to recognize. This is called a difference of perfect squares. This is what we're going to start with today. It's always subtraction, and these will always be perfect squares. When we factor it today, what's the square root of 16? 4. What's the square root of 25? 5. One's plus, one's minus. Boom. Like that's how the pattern works every single time. If you can identify that they're perfect squares and you know how to take a square root, you're good. Perfect square trinomials are a little bit trickier. The pattern here, well, I'll get there in a second. We'll come back to that. But we're going to start today with the difference of perfect squares. So anytime you see a difference of two things that are perfect squares, meaning these numbers, or an x squared or a variable squared, they'll always factor the same way. 1 plus, 1 minus, all we're doing is square rooting the first term, square rooting the last term, and writing out your two binomials. Okay? So for example, and this only works when it's a difference, so it has to be subtraction. So our first example up at the top here, we have x squared minus 25. That is a difference because it is subtraction of two perfect squares. What's really the number in front of x squared here? 1. And 1 is a perfect square. So this will factor into the following pattern. We square root the first term. What's the square root of 1x squared? 1x. We square root the last term. What is the square root of 25? We make 1 factor plus and 1 factor minus, and there's your 2 factors. Now, I don't typically write 1x, we would just write it as x, right? And if you wanted to double check yourself, you could by just multiplying it and making sure that you get this as your answer, which wouldn't take you very long. If I wanted to even use box method, I could quickly do that. X squared, 5x, negative 5x, negative 25, that'll cancel. Boom. X squared minus 25 is what I get. I know my answer is correct. B, 4z squared minus 1. How do I know it's a difference of perfect squares? Because this is a perfect square, this is a perfect square. Also, a difference of perfect squares will never have a middle term. It'll never have just a variable on its own without an exponent. That's another indicator. And it will only ever be 2 terms. What's the square root of 4z squared? 2z. And what's the square root of 1? 1's plus, 1's minus, and there's your 2 factors. And again, if you wanted to double check yourself, just multiply it out really quick and make sure that you get 4z squared minus 1. I also just want to remind people how square roots work. So if I asked you what the square root of 49 was, that would be 7. If I asked you what the square root of 169 was, that would be 13. So it's just a working backwards. Squaring to get the bigger number, square rooting to get the smaller number. We're going to try one more together, and I'm going to see if you can do number 2 on your own at the bottom here. We're going to skip the special product with the numbers thing. That's kind of silly in my opinion. All right, we got x squared minus 36. Two perfect squares, subtraction in the middle. Who can raise their hand and tell me the square root of x squared? Great. X, very good. 1x. Who can raise their hand and tell me the square root of 36? Alexis? 6. 1 factor's plus, 1 factor's minus. That's what makes the middle term cancel, because 1's plus, 1's minus, so they make 0 together. And there's your answer. Yeah. It's literally just, you just have to see the pattern, and then it is easy. It's pretty easy if you can just recognize the pattern that you're looking at. Now today on your homework, I'm going to give you, specifically it says it's a difference of perfect squares, but eventually you'll have to actually recognize that pattern. All right, I want you to try number 2 on your own. Let's see if you can get that one.
Oh.
Who thinks they have it? Claudia?
3n plus 4, 3n minus 4.
Perfect. Nice. Square root of 9n squared is 3n. Square root of 16 is 4. 1's plus, 1's minus. There's your 2 factors. If you want to check it, you can go ahead and multiply it, and you should get 9n squared minus 16. That's pattern number 1 of the day, a difference of perfect squares. So now I'm actually going to have you take out, we haven't looked at it in a while, I gave you guys a factoring flow chart. I think some of them were maybe blue or yellow. I can't remember now. Maybe yellow.
Yeah.
Okay. Looks like this at the top. Because typically we allow you to use this on the test if it helps. So I'm going to try and write down a couple things that might assist you on the day of your test. And we haven't really used this just yet. Once we learn the final way to factor, then we'll use this a little bit more. But on this flow chart, down here where it says, are there 2 terms, one of the follow-up questions is it a difference of perfect squares? So what I'm going to have us do here is just kind of star that and then write an example of what that looks like. So I'm just going to take one off of our notes here. I difference of perfect squares could be like 9x squared minus 16. I did not mean to put a parenthesis, sorry. That would be an example of a difference of perfect squares. And the way that factors every single time is you square root the first term and square root the last term. One's plus, one's minus. And make an extra note here that it's always subtraction. Okay, so let's just add an example of what that would look like so that come time to test, they're not all going to look like that, obviously. They won't always be 9 and 16, but at least I have some kind of little reference point to look at when I'm looking at my test. If I see two perfect squares subtracted, maybe it's this pattern. Pattern number 1. Pattern number 2 is going to be a perfect square trinomial. May I continue? Anybody still writing? Alright, so that's going back to the first one I did over here. This one's a little bit harder to recognize. Now, the first and last term will still be perfect squares. So 9 and 4 are still perfect squares. The middle term will always be, and this is very wordy, the square root of this times the square root of this doubled. So what's the square root of 9?
3.
Square root of 4? 2. 3 times 2 is 6. 6 doubled is 12. So that's how you recognize a perfect square trinomial. That one's a little more far-fetched. But again, I think the biggest thing to recognize is if you see a perfect square here and here, check and see if it's a perfect square trinomial. So as we look, and again, here is exactly what I just said, and here's even a couple of examples for you to reference. If I look down here, now you could definitely factor this normally and just look for two numbers that multiply to 16 and add to 8. And frankly, if it were me, that's probably what I would do, just because it's quicker. But you'll notice that those two numbers would be 4 and 4.
Yeah.
Now, the perfect square trinomial pattern would say, okay, recognize that this is a perfect square, 1, and this is a perfect square, 16. What's the square root of 1? What's the square root of 16? 1 times 4 is 8. Doubled is 16. 1 times 4 is, I literally did this last hour. 1 times 4 is 4, Miss Kelly. Doubled is 8. That's how I know it's a perfect square trinomial. The actual factoring part of it is really not that bad. The square root of 1n squared is n. The square root of 16 is 4. And then you just drop down the sign of the middle term. And there's your answer. We're going to do a couple more so before you're like, huh? I know, that was just the first one. Just to make sure it's a perfect square trinomial, we multiply the square roots and double them and make sure it's the middle number. I'll show you that again in a second. I think I have some of that little shuffle. Okay, we're going to look at this one, for example. This one, the leading coefficient was 1. Do you recognize that both of these numbers on the outside are perfect squares? Okay. Here's how we check and see if it's a perfect square trinomial. What's the square root of 4? What's the square root of 9?
3.
What's 2 times 3? What's 6 doubled? Okay, it's a perfect square trinomial. This number in the middle will always be the square root of this times the square root of this doubled. And like, you can use the Xbox still. That's still an option for you. You could still use that here. It's just sometimes these numbers will get really large and the Xbox is going to take you a lot longer. If you can recognize the pattern, that makes things a little bit quicker. Now, when you actually factor it, the factoring part is easy. Square root of 4x squared is 2x. Square root of 9 is 3. Drop down the sign of your middle term. There's your answer. As long as you can square root, that factoring part's actually not so bad. The hardest part is just recognizing that it's a perfect square trinomial. That's your answer. double check that, you absolutely could. You could just, if I wanted to double check it, just multiply it out really quick. 2x minus 3, 2x minus 3, 4x squared minus 6x minus 6x positive 9. Yep, that would multiply to 4x squared minus 12x plus 9. So you can always double check your answers. On your flowchart, just real quick, let's go ahead and add an example in here. So down here where it asks if there are 3 terms, it asks you the follow-up question, is it a perfect square trinomial? And that's what I was talking about. It's always 2 times the square root of the outside numbers. Let's write an example of what that looks like. So I'm just going to use the one that we just did. 4x squared minus 12x plus 9. And I recognize that the first and last term are perfect squares. That's always the indicator that it's one of those special products. And it multiplies the same way each time. Square root of the first term. Square root of the last term. Drop the sign of the middle number. And there's your answer. So they're just patterns that you see, and then they fall into the same pattern every single time. The only other thing I'm going to have you guys add right here is just the guess and check thing. Let's add in the X from the last couple of days here. Just again, oh my gosh, I'm making all the same mistakes I made last hour. Kelly, what's going on? Okay, I'll probably also leave that on the board the day of the test, but it might be nice to just have that written on your flow chart so that when you get to the test, you can use it just right there in front of you too. And remember, that X just helps you get the diagonal boxes. It's not like a magical formula or anything. It just helps you get the diagonal boxes. Megan? Okay. Okay. So your homework tonight is going to be actually pretty straightforward because I'm telling you up front that it's one of the special patterns. So pretty much as long as you can square root numbers, this won't take you very long. I'm going to do 2 with you real quick. But the hardest part is that when we get to all of the factoring, you have to pick and choose which method you're using. Xbox, regular, special patterns, but we'll get more practice at next week.
Good.
What'd you say? I have whichever ones you guys want to. 1 from each section. So
7. 7 and 7.
okay, from the top chunk of questions, which one do you want to do? 7? So okay, this is actually a really good one to talk about because 7 is why knowing the pattern is helpful. You could do the Xbox method, you could, but you would have to multiply 196 times 9 to figure out your diagonal boxes. That's going to take you a really long time. Guess and check is going to take you even longer because you got 196 is that first box. So if you can recognize that these are perfect squares, that makes your life a little bit easier. So this is going to factor the same way every single time. This is a perfect square trinomial. You take the square root of the first term. What's the square root of 196m squared? 14m. The square root of the last term, 3. Drop down the sign of the middle term, and there's your answer. Every single time. It's easy when I tell you up front that it's the pattern. It's just, it gets harder when you have to recognize the pattern for yourself. But yes, I agree.
Did you get it on the test?
All right, how about from the next 8? You said 7?
Yeah.
So 7 is a difference of perfect squares. I think these are pretty easy to see because it's only 2 terms instead of 3. What's the square root of 289x squared? 17x. And the square root of 9 we just said was 3. And in this pattern, one's plus, one's minus. And I remember that because there's no middle term, so that's what would make 0, the plus and the minus together. And that's your answer. So once I tell you up front, like, hey, you're using this pattern, the pattern itself is not difficult if you know how to take square roots. Now, lastly, as you guys finish, I do have a key up at the front for you guys to check. I told you were going to turn in those blue worksheets today. Some of you might have a white worksheet, but the worksheet from yesterday that had 8 problems on it, I would like you to turn that in, please. We will go ahead and just turn it in. You can just come bring it to me.
Good. This one will be
The one from yesterday. It said 7475 review. That was a misprint. It should have said 7576. My bad. Sorry, okay, thank you. Okay, let me collect them first and then I can help. We did not collect that one. Okay, just the blue. Will you please do me a favor and actually write the factors out for me? So like you did it here, but on these. All right.